Welcome to Module 8 at PCC 240M, and we are almost to the end of our term, so you've gotten to Module 8, you're doing great. Let's go ahead and take a look at server and network monitoring. We're going to understand the importance of server monitoring, use the resource monitor, and task manager, along with performance monitor. So let's take a look. Server monitoring is performed for lots of different reasons. One of the best ones is the baseline. So when you first install a server, you want to make sure that it's operating at a certain level. The processor's not pegged, the RAM is not fully used, and the hard drives are not showing at 100% usage. And so once you do that and you start using your server, installing other applications, you can go back and check to see if that server has changed that much since adding these applications and users that access them has done. So if it's significantly slowed it down, then at that point you probably want to get more resources, add more RAM, whatever it is that is the bottleneck. Resource Monitor, that's a different program. It provides a real-time snapshot for monitoring CPU, memory, disk, and network. And this is the only one I've seen that reliably checks out what the disk is up to. So when you go to Task Manager, you're just not going to see disk activity. You need to go into Resource Monitor to see the disk activity. Performance Monitor does it as well in a much more granular fashion even. But the Resource Monitor shows you a very quick way to tell whether your hard drives are being fully used at like 100% or not without having to set up a lot of background stuff. So you just take a quick look, quick analysis, tells you what the bottleneck is, what's running at 100%. And here's what Resource Monitor looks like. So you can see the CPU is expanded. The disk and the network are not. Those are all minimized at this point. But you can see the processor. You can see processor, the second one there, is very well used, but the other ones are not as well used. So it kind of tells you what's going on there. And it tells you the executable files that are all running as well. And then you go down to disk. If you expand that, it would tell you what's going on with the disk, the network, or the RAM. Processors in a server can be a bottleneck. So the processor may not have enough speed, it may not be efficiently run applications, because we all know programmers are not as good as they think they are. And memory bottlenecks can also be caused by insufficient memory or inefficient programs. Hard disk is what I find to be the biggest bottleneck nowadays until we move over to SSD drives. If you're using SSDs, you're probably not noticing this, but if you're not, then this is probably your bottleneck. This is probably where everything is running the most slow. So your network performance is typically not a bottleneck nowadays with 10 gigabit NICs. And I don't even see most NICs get used at a full 1 gigabit, let alone 10. So you're probably fine there. But if you need to, you can combine the network cards together. You can access server services through the Server Manager or the Computer Manager tool. So this gives you a graphic of all the different services that are running on your computer, on your server. It tells you what's running. If it says that it's automatic, it should be in running. If it says in manual, some will be running and some will not. And then if it says disabled, then they will not be running. So when you experience a problem on a server that has a service that goes with it, you check the status of the service to make sure that it's started. So you can stop, start, pause, resume, restart, all those different things. Now, sometimes it gets stuck in the stopping or starting phase. In that case, you could either restart the server, which is very inconvenient most of the time, or you could go to the associated executable by right-clicking on it and choose go to details. And then you can kill the executable, and then that will take it out of the stopping or starting phase, and then you can restart it at that point. So we have a Task Manager tool as well. Task Manager, of course, built into every Windows computer for decades. And you get to it by pressing the Control-Alt-Delete while logged on as administrator or as a member of the administrators group. So the Processes tab, it shows all the software application, background processes, all the Windows processes running. So let's take a look and see what that looks like. So there's processes, and you can see the CPU and memory. Now in a Windows 10 computer, you can also see the disk, but you don't see that in a server operating system. You see the apps, the background processes. You scroll down, you'll see system processes. It shows a lot of good information, CPU and memory that they're using. If you right-click on an app, several active options appear. You've got expand, restart, end task, open file location, all those different things. So if you went back to that previous graphic, you could right-click on any one of those and you would see all these different options. Details tab lists the processes in use by all running applications. If you need to stop a process, highlight it and click End Task. And again, if there's any services involved with it, it will end those services as well. So here is the Details tab, and you can see the executable files. And take a look at the PID right there. So that PID number matches the PID in the services, so if you're and also in the processes. So if you're ever not sure, because for instance, some of these different names look a lot alike, and so you're not sure what they are, like CRSS, what does that go to? Well, if you right-click on it and go to service, it'll tell you which service it's tied to. So here's all those different options we were talking about. One of the options I like is the set priority. It tells what type of processing horsepower you should give that particular executable. Services tab in Task Manager shows the services that are started, stopped, or paused. So here is the Services tab all the way right. And as I mentioned earlier, if you have a stuck service, you can click on Go to Details, and then you can end the executable that's tied to it. So here you can stop and restart and open services right from that menu. Performance tab shows vital CPU and memory performance information. This is usually the first one that I go to. So one of the things that shows is a handle. And that's a resource such as a file used by a program. Threads are blocks of code within a program, so they're parts of a program. And then there's committed memory, number of bytes a process has designated. Then we have the paged pool and non-paged pool. It has to do with RAM. Represents data that can be stored in the paging file, which is the virtual RAM, and so can be paged in and out of virtual memory. The non-paged pool holds the operating system kernel and device drivers that cannot be paged out. So these are things that cannot be put into the paged pool. Problem is if once again you have poor programming, which we most often do, then you end up, if the paged pool goes down to 0, the server just stops to work. You have to restart the server. And if you have too much of a problem with that, you'll have to get a patch for that application. Or if it's a Windows service, you'll have to get a service pack or a hotfix to fix it. Page faults occur when memory pages are called by a program or processed from the page file on the disk. So every once in a while, you will get a page fault because the paging file is having a problem. Usually restarting the server will fix that issue. So here is what the Performance tab looks like in Server 2016. You see the CPU, the memory, and the Ethernet. Like, hey, I want to see the hard disk. No problem. Click on the resource monitor at the bottom. It'll take you to that resource program we talked about earlier on in the module. Here's what the memory looks like. Looks like a pretty steady amount there. And in this, you'll also see the paged pool and the non-paged pool information I talked about earlier. And you really want to have data in that non-paged pool. Otherwise, that server will stop functioning. And I have had that happen before. Network performance information shows real-time send and receive data through the network. And it's a lot of great information in case you're having a problem. So when a virus gets released on the network, one of the first telltale signs is the network in Task Manager is completely pegged at 100%. So here's what that looks like. You can see we've got 2 different Ethernet cards here, and you can see the traffic that's going on with this particular card. So 16 kilobits per second. It's not hardly being used at all, which is great news. Monitoring users. The Users tab provides a list of users currently signed in. I've actually caught hackers this way. So if you are not sure whether someone has hacked into the computer, you can go to the Users tab, and you can see people logged in that shouldn't be. So a lot of times this happens when you have a small company that gives everybody in the company administrative access using a really simple password. Somebody hacks in from the outside, and then they take control of the server. So here is the Users tab, and you can see the only person logged into this server is the administrator. And the administrator is running all these different programs. Performance monitor can be used to monitor components such as hard disks, memory, processor. So this goes a step further than resource monitor. Can be opened from Server Manager and MMC Snap-in, lots of different ways to get there. And there's counters. There are hundreds and hundreds of counters in this thing, and they get very granular. So you kind of have to know what you're doing in order to understand what it is that you're looking at in Performance Monitor. So in this particular case, we can see there's only one monitor going. It is the percent processor time, percent processor time. So that's how much the processor is being used at this moment. And you can add additional ones by clicking on the plus sign or delete them by clicking on the X. And you'll get a list of hundreds of different types of counters. Here's some of those that you can see right here for the local computer. And you see processor time is the default, but if you scroll up and down there, you'll see lots of categories and subcategories in there. So in monitoring performance of a server, 4 objects are often used. Well, out of these hundreds of ones, which one should we do? Well, the processor, of course, memory, physical disk, and network interface. But that kind of already tells us, or has been told to us through the resource monitor. Those 4 things have already been told to us. So how do we make this better? Well, you can use some of the subcategories, the hundreds of other counters underneath processor, memory, disk, and network interface. So you can get very granular in which part of the network interface is causing the problem, which part of the physical disk is causing the 100% lockage. And then you can mitigate that issue once you realize which one it is. Data collector set tool is very useful. It's used to monitor performance over time. So it's a set of collection and diagnostic performance in a report or a log. So instead of showing it as a graph as you did here, you can see this in a log file, and you can let it run for hours or days or however long you want. Now you don't want to let it run forever because it does slow down the server, but if you want to get a good idea of what's happening on your server and you don't want to just see what it looks like at that moment, you want to see what it looks like over time, then the collector set tool is the way to go. So performance counter report, it tracks information using object counters and instances. You've got a trace monitors particular events if you wanted to monitor events that happen, such as when a processor hits above 80% or when RAM falls below a certain amount as well. So you can have those alerts let you know when that happens. There are templates that can be created from the new data collector set. So if you're not sure how to set this up, you can use one of the templates, and there's several here that you can pick from that will do what you need them to do. So you don't have to be an expert in it just to set it up. After you create the report, you can go back to it by finding the report under the Reports tab, and then you can go ahead and view that and see what's going on. So you want to gather as much data as possible on the network interface performance, IPv4 and IPv6, and the performance counters if you decide to choose the network template. Performance Monitor has lots of different predefined data collector sets, as I mentioned earlier, and that you can run anytime without first creating them through the Create New Data Collector set. Server monitoring enables you to establish benchmarks and baselines. So this is one of those things we talked about earlier about setting a baseline. So this is where you would do it, through these collector sets. You let this run maybe for an hour, maybe 2, see what the collector set says about your 4 big categories we just talked about. And then you can come back and do this again after changes have been made, maybe 6 months or a year down the road, to see if there's any significant changes. All right, well, we talked all about data collector sets, performance monitors, resource monitors, server monitoring, all these different things to help you fine-tune your server and make sure that it continues running for a long time. What's a long time? Well, average server runs for about 3 to 5 years of useful life before it slows down or stops working correctly. So that does it for Module 8. We'll see you in our final module, Module 9.